Here we have three long wires A, B and C shown as cross-section which is coming out of screen. The wire B and C has current going into the screen and the wire A has current coming out of the screen. We are asked to find the force per unit length on the wire A from the other two wires. I will solve the problem from two facts, as some of you may already know. But do not worry, I will later prove these two facts from the more basic formulas. Since the wire A will be repelled by B and C as the current is moving in opposite direction, the force per unit length on A from the two wires are written as this. The force in the figure is shown in the red. The resultant vector addition is the total force per unit length. At this point, the physics is done, but the math is a bit complex, so we'll walk you through the critical points. To calculate the magnitude of the force per unit length, we square the vector by taking the dot product with itself. Continuing with the math, we substitute the value and reduce to get the magnitude of force per unit length. Now let us calculate the angle of the resultant force. To calculate the angle, we like to simplify the calculation by taking this xy coordinate system, which is x along the force BA. You may recollect that for any vector, tan of the angle is y component divided by x component. Here we did the tan for the resultant vector, and we need to find the angle. The FBA has no y component. Rest is a simple calculation, and we get the angle as 40.89 degrees with respect to x. To calculate the angle of resultant force with respect to horizontal, we need to add 60 more degrees. We are now in position to write the complete answer. Now we derive the force per unit length between two wires as I have promised before. The formulas that are shown in red boxes should be learned by heart. We will use them to get the forces between two wires. Let's say we have this long wire of infinite length where a current I1 is flowing. From Ampere's law, we will find the magnetic field at a distance d as follows. The direction of the magnetic field is given by Ampere's right-hand rule. So from the Ampere's right-hand rule, we see that at a point P above the wire, the magnetic field will be coming out of screen as shown. Now let us have another wire that passes through the point P, and the current is moving in opposite direction. We will focus on the force on the small element delta L on the upper wire. We will use the second formula, which gives the force exerted by magnetic field in a small element delta L on a wire. So we have proved the magnitude of the force comes out as we expect. Now we will prove the force is repulsive. We start with delta L vector, which is defined as a vector in the direction of current I2 of the upper wire. We see that the cross product of delta L and magnetic field will be in up direction. Hence the force on the element will be in up direction. Now from the Newton's third law, a reaction force in opposite direction will be produced, and therefore two long wires carrying current in opposite direction will generate a repulsive force. That completes the problem, and that is all for now. Bye bye.